D4 writing data and output port. D5 reading first byte of an executable instruction. D6 reading data from an input port. D7 reading data from memory. 4 D5 5 D6 6 D7 7 D3 8 D2 9 D1 10 D0 11 5V. The 5V power supply. This must the first power source connected and the last disconnected, otherwise the processor will be damaged. 12 Reset input as A. The signal forces execution of commands located at address 0000. The content of the processor registers is not modified. This is an inverting input, the active level being logical 0. 13 Hold input direct memory access request. The processor I requested to switch data and address bus to the high impedance. Disconnected. State. 14 Input interrupt request 152 input the second phase of the clock generator signal. 16 Int output. The processor has two commands for setting 0 or 1 level on this pin. The pin normally is supposed to burst for interrupt control. However, in simple computers it was sometimes used as a single bit output port for various purposes. 17 By output read. The processor reads from memory or input port. 18 Root put write. The processor writes to memory or output port. This is an inverted output, the active level being logical 0. 19 Sync output active level indicates that the processor has put the state word on the data bus. The various bits of the state word provided information to support the separate address and memory spaces, interrupts and direct memory access. This signal is required to pass through additional logic before it can be used to write a processor state word from the data bus into some eternal register E.G. 8238 system controller on bus driver. 20 plus 5V. The plus 5V power supply. 21 would output direct memory access confirmation. The processor switches data and address pins into the high impedance state, allowing another device to manipulate the bus. 221 input the first phase of clock generator signal. 23 ready input way. With this signal it is possible to suspend the processor's work. It is also used to support the hardware-based step-by-step debugging mode. 24 wait output way indicates that processor is in waiting state. 25 A0 output address bus 26A127A22812V. The plus 12V power supply. This must the last connected and first disconnected power source. 29 A3 output the address bus can switch into high impedance state on demand. 30A4318A633A734A835A936A1537A14338A1339A1240A11. Support chips. A key factor in the success of the 8080 was the broad range of support chips available, providing serial communications, counter forward/timing, input forward/output, direct memory access, and programmable interrupt control amongst other functions. 8238 system controller and e-bus driver. 8251 communication controller. 8253 programmable interval timer. 8255 programmable peripheral interface. 8257 DMA controller. 8259 programmable interrupt controller. Physical implementation. The 8080 integrated circuit uses non-saturated enhancement load NMOS gates, demanding extra voltages for the load gate bias. It was manufactured in a silicon gate process using a minimal feature size of 6 m. A single layer of metal is used to interconnect the approximately 4,500 transistors, 17, in the design, but the higher resistance polysilicon layer, which required higher voltage for some interconnects, is implemented with transistor gates. The die size is approximately 20 mm. 2. The industrial impact. Applications and successes. The 8080 is used in many early microcomputers, such as the MIT's Altair 8800 computer, processor technology Sol 20 terminal computer and IMSI 8080 microcomputer, forming the basis for machines running the CP/M operating system. The later, almost fully compatible and more able.
Yes, it keep mentioning this Altair 88800 computer. I think I have to check if I have it. This is the Intel 8080. No, the Altair 88, I have to search wiki. I'm not sure I have it. Yes, I got the Altair 8088. We have to read that later. But let's now probably mess up. That's the Altair there. But now I probably mess up. I have to read that too. Because one of this 8-bit is used in there. And I think that's the Microsoft, the founder of the Microsoft, Bill Gates, and somebody else did build something like, I don't remember, but now probably I did stop this by, let's try to continue. Okay, I maybe...
The industrial impact. Disconnected power source. 29 output. The address bus can switch into high impedance state on demand. 30A4318A6338734835A93681537A1438A1339A1240A11. Support chips. A key factor in the success of the 8080 was the broad range of support chips available, providing serial communications, counter/timing, input/output, direct memory access, and programmable interrupt control amongst other functions. 8238 system controller and debus.
Yes, now I lost the text. I don't know where the text is. I don't know how.
Applications and successes. Would capitalize on this, with Z80 and CP/M becoming the dominant CPU and OS combination of the period circa 1976 to 1983, much as did the x86 and DOS for the PC a decade later. In 1979, even after the introduction of the Z80 and 8000.
Yes, now I lost track of the text. I should not do that. That's a mistake. Let's close this. I cannot open this one. Yes, we do this. Got to something like there, industrial impacts. But I don't know how to do. I'm not used. That's the first time I try this. I'm not going just like the program to read from like. Let's just read to the end of the document.
Disconnected power source. 29 output. The address bus can switch into high impedance state on demand. 30A4318A633A734A835A9368A1339A1240A11. Support chips. A key factor in the success of the 8080 was the broad range of support chips available, providing serial communications, counter/timing, input/output, direct memory access, and programmable interrupt control amongst other functions. 8238 system controller and debus driver. 8251 communication controller. 8253 programmable interval timer. 8255 programmable peripheral interface. 8257 DMA controller. 8259 programmable interrupt controller. Physical implementation. The 8080 integrated circuit uses non-saturated enhancement load NMOS gates, demanding extra voltages for the load gate bias. It was manufactured in a silicon gate process using a minimal feature size of 6 m. A single layer of metal is used to interconnect the approximately 4,500 transistors, 17, in the design. But the higher resistance polysilicon layer, which required higher voltage for some interconnects, is implemented with transistor gates. The die size is approximately 20 mm. 2. The industrial impact. Applications and successors. The 8080 is used in many early microcomputers, such as the MIT's Altair 8800 computer, processor technology Sol 20 terminal computer and IMSI 8080 microcomputer, forming the basis for machines running the CP/M operating system. The later, almost fully compatible and more able, Zilog Z80 processor would capitalize on this, with Z80 and CP/M becoming the dominant CPU and OS combination of the period circa 1976 to 1983, much as did the x86 and DOS for the PC a decade later. In 1979, even after the introduction of the Z80 and 8085 processors, 5 manufacturers of the 8080 were selling an estimated 500,000 units per month at a price around $3 to $4 each. 18. The first single-board microcomputers, such as Micro 1 and the Dynamicro/MMD1, single-board computer, were based on the Intel 8080. One of the early uses of the 8080 was made in the late 1970s by Cubic Western Data of San Diego, CA, in its automated fare collection systems custom designed for mass transit systems around the world. An early industrial use of the 8080 is as the brain of Datagraph iX Autocom, computer output microfiche, line of products which takes large amounts of user data from reel-to-reel tape and images it onto microfiche. The Autocom instruments also include an entire automated film cutting, processing, washing, and drying subsystem. Several early video arcade games were built around the 8080 microprocessor, including Space Invaders, one of the most popular arcade games ever made. Zilog introduced the Z80, which has a compatible machine language instruction set and initially used the same assembly language as the 8080, but for legal reasons, Zilog developed a syntactically different, but code-compatible, alternative assembly language for the Z80. At Intel, the 8080 was followed by the compatible and electrically more elegant 8085. Later, Intel.
Yes, I have to search this Z80 computer. This is the Intel 8080. Let's do this, but I have this Altair 80, but let's try Z80. I think Z80. But that's maybe not that one. Zilog Z80, that's the one there. We have to save this Zilog Z80. It was using this 8-bit microprocessor. So let's just download as a PDF. So this will take many hours. That can take like more than 100 hours. So just wait, my McAfee antivirus need to pop up, then I can save it. Yes, then I will save this. That's 27 pages, so that can take many hours, this program to read. So I cannot do that because only I need to charge my camcorder. So I will do that in a few days. I will save it to this folder, my Wikipedia folder. I will save it, then I will close it again. Close it and go back. There's a Zilog, then I will open the Acrobat Reader program and continue. And that could happen that it cannot remember where to continue when I do this. Read loud, continue.
Issued the assembly language compatible, but not binary compatible, 16-bit 8086 and then the 8/16-bit 8088, which was selected by IBM for its new PC to be launched in 1981. Later NEC made the NEC V20, an 8088 clone with Intel 80186 instruction set compatibility, which also supports an 8080 emulation mode. This is also supported by NEC's V30, a similarly enhanced 8086 clone. Thus, the 8080 via its instruction set architecture, ISA, made a lasting impact on computer history. A number of processors compatible with the Intel 8080 were manufactured in the Eastern Bloc. The KR580 VM80, initially marked as KP580K80, in the Soviet Union. The MCY 7880, 19, made by Unitra CEMI in Poland. The MHB 8080, 20, made by Tisla in Czechoslovakia. The 8080 APC, 20, made by Tungsram/MEV in Hungary, and the MMN 8080, 20, made by Microelectronica Bucharest in Romania. As of 2017, the 8080 is still in production at Lansdale Semiconductors. 21, Intel 8080 second sources. AMD M9080. Semi MCY 7880, Poland. Kvasa Kiev K580 IK80, Soviet Union. Mitsubishi Electric M5L 8080. National Semiconductor INS 8080. NEC PD 8080F. OKIMSM 8080. Siemens SAB 8080. Synetics.
Yes, I need to find this national semiconductor, because this is still in production. This is still in production by Lansdale Semiconductors. Okay, that's not the same. Probably I mess up again. No, let's just try to continue. This is the Tesla company, but that's not the Elon Musk event that name. Let's just
MP 8080. Tesla, Czechoslovak company, MHB 8080. Texas Instruments TMS 8080. Industry change. The 8080 also changed how computers were created. When the 8080 was introduced, computer systems were usually created by computer manufacturers such as Digital Equipment Corporation, Hewlett-Packard or IBM. A manufacturer would produce the whole computer, including processor, terminals, and system software such as compilers and operating system. The 8080 was designed for almost any application except a complete computer system. Hewlett-Packard developed the HP 2640 series of smart terminals around the 8080. The HP 2647 is a terminal which runs the programming language BASIC on the 8080. Microsoft's founding product, Microsoft BASIC, was originally programmed for the 8080. The 8080 and 8085 gave rise to the 8000.
Yes, we need this, the basic and Microsoft Basic language. We need to understand that because this is some of the, that's on page 13.